Hey, what is up guys? For this question, I'll be solving Leetcode 783, minimum distance between binary search tree nodes. And for this question, it's a pretty simple one where we're given a binary search tree and all we need to do is to calculate the minimum difference between any two values in the tree. So in this case, since we want the minimum value between two nodes, any two nodes, we can see that the minimum between this one and this one is just 1. And the minimum between this one and this one is 1 as well. So we can just return any one of these two, and the answer for this is just gonna be 1. So there isn't really any trick to this question other than you need to know what a binary search tree is. That just really simplifies it, since it's the answer is just based on one of the properties of a binary search tree, and the property of that is since in a binary search tree you have a parent node, and every node on the left is less than that parent node. So if this is 5, then this node can be greater than 5, so it could be 4, for example. And every node on the right side is greater than the parent. So this can be 6, but it cannot be like 4, for example. Since given this property of binary search tree, all we would need to do is iterate this tree in order traversal. So in this case, the in order traversal would be 4, 5, 6. And given that we know that this is in order and the binary search tree is going to be sorted from its property that we discussed, we can just simply return the minimum difference that we encounter when we go through this tree in order. Since this is a sorted array, when we iterate this tree in order, any two values next to each other, they're always going to give us the minimum difference compared to any of the other values in the array. So for example, if we find out that 4 and 5 here, the difference between them is 1. We don't have to worry about 4 and 6 because this array is already sorted. So there's no way that 4 and 6 are going to be closer to each other than 4 and 5. So that's really it for the overview of this question. And now I'm going to move over to the coding part and see how that's done. So now for the coding part, we're given the root as the input for this function. And all we need to do is just have an in-order traversal set up in place. So if we don't have a root anymore, we can just return. Otherwise, the in-order traversal goes like this. We visit the left tree first, do something here in the middle, and then we, like usually, print out the value, and then we go to its right tree. So here what we want to do is we actually just want to store the difference in a variable here, minimum diff, and we're just going to take the minimum between what we already have stored previously and subtracting the previous value, which we're also going to store in another variable, minus the root dot value. And then we can just simply store the previous value as the current root dot value. And just so we can initialize these variables first, we're going to set them to a really high number, so that when this executes at the beginning, the minimum difference won't get skewed over. So once we call this on the root, we can just simply return the minimum difference that we found. And that should be it for solving this question. And we can quickly walk through the code here to make sure that that does make sense. So in order traversal, it's going to start here at 4. Let me just switch on the cursor. So it's going to start over here at 4. It's going to keep going left until it hits this line where you can't go left anymore. Then it goes back to 1. And it does this line right here, where it stores the minimum difference as like a very high number, essentially, because the previous and the minimum difference are just going to be infinity, essentially. So it's just a very, very high number. So once it goes back here, it's going to store 1 as the previous. Then it goes right. So once it goes right, there's nothing on the right side of 1. So it still goes back here, and then it returns the stack back to 2, where it hits this part again. And now it's going to do the previous, which is 1 minus 2, and take the absolute value of that. Now the minimum difference is going to be 1. And the previous is going to be 2. So now it goes to the right side of 2, which is 3. And once it goes to the left side now from 3, it's going to return, since there's nothing, goes to the right, it's going to return, there's nothing. And before it goes to the right, actually, it's going to execute the same thing here, calculate the minimum difference, which is still 1, and store the previous as 3. And then it's going to go all the way back to 4 and essentially do the same step again, but instead of visiting left side, it visits the 6th 6 node, but before visiting the 6, it's going to go here and do the previous, which is 3 minus 4. And it's not going to update this actually because it's still, the minimum difference is still 1. And we can actually quickly test this. So if we make the 4th node to be 5, for example, and the left is 2, 6, and the left of the second one is 0. And this one is 4, then the minimum difference should still be 1, since it's going to compare this value to this value. Hopefully that made sense, and thank you for watching.